Well, hello everyone. Here for this video, I'd like to kind of complete some things that I missed on the first video about how to write formulas for ionic compounds. So this one is called part 1.5. It's an addition or an addendum to part 1. A few things that I overlooked, 3 to be exact. First and foremost, it's really important for you to know the term binary compounds. All of the compounds in the previous video were what we like to call binary compounds. And what does that mean? Well, a binary compound is made of exactly 2 elements. Here are some of the formulas that we wrote in the first video, and you'll notice that each of them has exactly 2 elements, such as nickel and sulfur, gallium and nitrogen, etc., etc. This does not mean that there has to be exactly 2 atoms of each element, or literally only 2 atoms, just 2 elements, and that is all. There are other compounds that have 3 or 4 elements in them, and we're going to look at them in a later video. But for now, this video that you just watched only involves what we call binary compounds. That's a term that chemistry teachers like to use a lot. If you're looking up other materials on the internet to help you study, you will see that term binary compound. By that definition, our good friend water, H2O, is also a binary compound, given that it's made of only 2 elements, hydrogen and oxygen. The second thing I'd like to add on is kind of a convention in how these ionic compound formulas are written, and that convention is that the first element written is the one that has the positive charge, and the second one written is the one that has a negative charge. That's a rule that was created by the chemistry people, and it's a rule that you should follow if you wish to kind of speak the language of chemistry people and be able to communicate with them. For example, the formula for magnesium bromide begins with magnesium. Magnesium is the metal with the positive charge, and the formula ends with bromine because bromine is the nonmetal with the negative charge. If we were to reverse the sequence of those elements and keep the subscripts the same, then we would have this formula here. Now, in a manner of speaking, this formula isn't wrong. There is a measure of accuracy in it, in that it does show 2 bromine atoms combining with 1 magnesium atom, just like this formula here. However, this is wrong, in the same way that the word cat is not spelled K-A-T, or that the formula for water is OH2. If you were to write this formula, then, well, I don't know what to tell you, but clearly you weren't trained in chemistry very well, and that's what I'm trying to do here, is train you to be a good chemist that can speak the same language of chemistry and follow all the same rules that all the other chemists do. So whereas this is somewhat accurate, sorry, it's not acceptable. Thirdly, there are 2 metals whose charges you should commit to memory, and that would be silver and zinc. Silver ions always have a +1 charge. Zinc ions always have a +2. Why do I say that you should commit those to memory? Well, here's why. If we look at silver and zinc in the periodic table, we find silver here and zinc up here. And they're both in this zone of the periodic table that we like to refer to as the transition metals. Many of the transition metals are multivalent, meaning they have more than 1 possible charge. But silver and zinc are kind of an exception to that rule, silver only ever having a charge of +1 as an ion, and zinc only ever having a charge of +2 as an ion. So that does define them as monovalent metals, and they don't fall in the periodic table in the same place as many of the other monovalent metal ions. So, as a chemistry student, it really will be very helpful for you to commit those 2 ion charges to memory. Silver having a +1 and zinc having a +2 charge. That's all for now, everybody. I hope you're all having a great day, and I wish you all HAND, which stands for have a nice day.